In a small village, a cat named Whiskers discovered a magic fish in a pond. The fish promised 3 wishes in exchange for its freedom. Whiskers wished for endless fish, a cozy bed, and a bell that rang softly. The fish granted all 3 wishes and swam away, leaving Whiskers content and purring in the sun. The ground beneath us feels solid, permanent, reliable, but in an instant, it can move with unimaginable force. An earthquake can shift landscapes, reshape cities, and alter lives in seconds. Today, we explore the science, the history, and the impact of major earthquakes. This is when Earth shakes, the power of a major earthquake. Earthquakes happen when stress builds up along the Earth's crust. The crust is broken into plates that move slowly over time. These tectonic plates push, pull, and grind against one another. Most of the time, the movement is too small to notice, but pressure can build for decades or even centuries. When the rocks can no longer hold, they break. The sudden release of energy travels outward as seismic waves. That is the earthquake. The scale of earthquakes is measured using magnitude. A small earthquake under magnitude 3 may pass unnoticed. A major earthquake over magnitude 7 can release energy equal to several nuclear explosions. Unlike storms, there is no visible warning. The ground can simply lurch without notice. Earthquakes are more common along fault lines. One of the most famous is the San Andreas Fault in California. Others circle the Pacific Ocean in what scientists call the Ring of Fire. This region experiences around 90% of the world's earthquakes. Throughout history, major earthquakes have left deep marks on human civilization. In 1960, Chile was struck by the largest earthquake ever recorded. It measured magnitude 9.5. The shaking lasted 10 minutes and triggered tsunamis across the Pacific Ocean. Waves reached as far as Japan and the Philippines. Thousands of lives were lost, and the country was permanently reshaped. In 2004, a massive undersea earthquake near Indonesia reached magnitude 9.1. The event set off one of the deadliest tsunamis in modern history. Coastal communities across the Indian Ocean were devastated. Over 200,000 people died. It showed how earthquakes beneath the sea can have far-reaching effects. Another example is the 2011 Tohoku earthquake in Japan. This magnitude 9.0 earthquake caused severe shaking, a tsunami, and nuclear plant failures. The disaster demonstrated how interconnected modern societies are. One earthquake affected energy, transportation, and economies worldwide. Even earthquakes of lower magnitudes can be destructive in populated areas. In 2010, Haiti experienced a magnitude 7.0 earthquake. The shaking was brief, but buildings collapsed across Port-au-Prince. More than 200,000 lives were lost. The scale of tragedy came not only from the earthquake itself, but from limited infrastructure and response capacity. Earthquakes remind us that the ground is not fixed. The forces that shape continents are still active today.
Okay, team, move in.
Studying earthquakes helps scientists prepare for future events. Seismology, the study of seismic waves, reveals where faults are located and how they behave. While predicting the exact time of an earthquake is not yet possible, scientists can estimate risk zones. These maps guide building codes, emergency planning, and community awareness. Preparedness saves lives. In Japan, strict construction standards require buildings to sway without collapsing. This engineering reduces casualties during strong shaking. In other regions, early warning systems can detect initial seismic waves and send alerts seconds before the main shock arrives. These moments can allow trains to stop, power plants to shut down, and people to take cover. Yet vulnerability remains high. Many cities sit directly on fault lines. Population growth places more people in hazard zones. Older structures, built before modern codes, may not withstand shaking. Earthquakes also disrupt water supplies, electricity, and hospitals. The effects ripple beyond the immediate damage. Climate and disaster research shows that recovery is often uneven. Wealthier areas may rebuild quickly with stronger systems. Poorer regions may struggle for years. Understanding this gap is essential for global resilience. When Earth shakes, it reminds us of our place on a restless planet. The crust beneath us is dynamic, moving in slow motion until it suddenly is not. Major earthquakes release power beyond human control. But human choice, how we build, prepare, and respond, shapes what happens next. History shows us the destruction earthquakes can cause. Science shows us how to reduce the risks. Preparedness and knowledge are our strongest defenses. The ground may not be as solid as it seems, but with awareness and action, societies can withstand the shock. This has been When Earth Shakes, the power of a major earthquake.